Earlier on, you saw a screen with a bunch of different UniFi products on them. And what I'd like to do now is start talking about what they are and how they work together. But before I do that, I want to talk very briefly about traditional wireless routers. And what I really want to touch on here are some of the problems that UniFi solves. So let's start with this generic no-name traditional device. Now, as I said earlier, you would normally put this in one location in your house, and you'd have a very good signal in that one place in the house. And then as you moved further away to other locations, other rooms where we now suddenly expect Wi-Fi, connectivity is suddenly not so good. Now, this one unit is tasked with doing many different things. So obviously it is a wireless access point. They're usually also a switch, and they'll frequently have multiple Ethernet jacks on them as well. This one device also acts as a firewall, and of course it provides an administration interface. So you see how this one unit does everything. Sits in the one spot in the house, does Wi-Fi switching firewall admin. And then, very often, it's not updated. I've certainly had products like this in the past that would go for years and years without any updates. Now that means no security updates, and it also means no feature updates. It still did exactly the same thing it did 5 years later as on the day I bought it. So what I was ending up with, and indeed why I went and bought UniFi products in the first place, was old equipment that was going unloved by the manufacturer, gave me very patchy Wi-Fi across my house, and really didn't give me any options in terms of how I could actually expand that network to cater for my family's ever-increasing appetite for Wi-Fi connected things. So let's now compare that with the UniFi ecosystem. And we'll start again with wireless access points. Now I'm just going to start with one AP, and I'll explain precisely what this unit is shortly. But the important thing for now is that this is all it does. It provides Wi-Fi, that's it. If I want to have a switch, I'm going to need to add a switch. And there are multiple different choices we have for which switch we should choose. But the point is that it is a discrete unit that does that one thing very well. Now, I'm going to want a firewall on my network as well, so we'll add in one of those, and inevitably on the other side of the firewall is going to be the internet. But there's also a fourth component that I mentioned on the previous slide, and that's the administration. So we'll add one of those as well, and that is a separate unit within the UniFi product suite. So in many ways, what we're looking at here is actually a deconstruction of that old single unit that does everything. And by deconstructing it, we can choose what are the right scale units for our particular install. Not only that, but we can then build it out further. So for example, by adding more wireless access points. So there's that modularity which I mentioned earlier on. Every one of these units you see here runs firmware, and every one of them is regularly updated by Ubiquiti. So it keeps improving, frequently adding new features and new ways of getting the most out of your network. Now, one of the key tenets to building out a UniFi network is that, as per the diagram here, you're going to have multiple access points. And this brings us to another really important characteristic of the UniFi ecosystem: fast roaming. This recognizes that a UniFi network is often going to have multiple access points spread around the premises. And what we want to be able to do is have someone who is connected to one unit move, say, to another room, and then become connected to another unit, and then go to another room and connect to that unit, so that they continue to have the best possible Wi-Fi experience as they move around. The great thing about UniFi is that this client only sees the one network. There are multiple APs around, but they're all broadcasting the one SSID, and the roaming is a seamless experience. So you can, for example, be having a VoIP call on your smartphone, and moving around the house or around the office, and the client simply roams from one access point to another, picking up a faster connection as it moves further away from the old one and approaches the new one. Let's now go on and start talking about some of the components of this UniFi product suite. I want to start with access points, but I'm going to talk about 3 different classes of access point. And the first class is per room Wi-Fi. Now you'll see what I mean by per room in just a moment. But one concept I want to establish before I get into that is that as I go through these 3 different classes of access point, we're going to be talking about a spectrum. At one end of the spectrum, we have products designed for less users. At the other end are products designed for more users. Now equally, at that less user end, we're going to have less performance. At the more user end, we're going to have more performance. And this is a theme we're going to keep coming back to for a bit. So let's actually take a look at the first unit. And it's an AC in wall. Now, let me just give you a good visual representation of what this looks like installed in a room. And it simply sits there on the wall, just like you'd find with a power socket. It's a very flush, non-obtrusive unit. And as well as being an access point, it has 2 Ethernet jacks under the bottom of it as well. So imagine a use case where you would have installed Ethernet jacks into a room, except now, rather than just having them provide a wired connection, it also does wireless as well. Now a use case like this one might be in a hotel, where every room has its own in-wall access point, providing it both Wi-Fi and physical connectivity. You could also do the same thing in a new house. I've done this with an install myself. We put 7 of these across the house, 1 in each room, so that not only did we have ubiquitous Wi-Fi across the house, so there's that theme again, but we also had physical connectivity everywhere we could possibly need it. So going back to that in-wall unit for a moment. First of all, it supports both 2.4 and 5 gigahertz, and every single Wi-Fi device you see in this course does the same. Every single Wi-Fi device also supports 802.11b, G, A, N, and AC, so every single modern protocol we could hope for. The next unit is an AC in-wall Pro. It supports faster connection speeds and more users. So this is a unit you might put in a location where there's going to be a higher density of users. And you can see that represented here on the image. Of course, one thing to be conscious of, regardless of which access point it is that we're talking about, is that we're looking at maximum speeds and maximum users. And that doesn't necessarily mean you're going to have both at the same time. So if you genuinely expect that you're going to have 100 users, and you do actually want to have high throughput speeds, you're probably going to need multiple units. Then there's the range. Yes, you might get coverage out to 100 meters, but that doesn't mean you're going to get maximum throughput out to 100 meters. So if you did actually need to cover that distance, you may well, again, be looking at requiring multiple units in order to get optimal performance across the environment. One more thing about the in-wall units. They take power over Ethernet, or PoE. So in other words, you don't have a separate mains power unit for them. This means you'd normally have power delivered by a device such as a switch, which was PoE enabled, and we'll talk more about that a little bit later on. As I mentioned earlier, the in-wall units have 2 Ethernet jacks, and one of those is also PoE enabled. So you can power the in-wall unit off the power delivered by a switch, and then power another downstream device which is plugged into the in-wall unit. The second Ethernet jack doesn't provide power, it just provides data. Let's go and look at another suite of Wi-Fi products, and it's general purpose Wi-Fi. Now we're going to use this same spectrum again, less users and less performance versus more users and more performance. And we're going to start with the AP-AC Lite. Now this is one of these disc-shaped access points which has become synonymous with the UniFi product range. Like the in-wall unit, the AP/AC light is also powered over Ethernet. And incidentally, if you want to connect it to a switch which is not PoE enabled, you can always use a PoE injector, which is a unit which does plug into mains and then adds power inline via an Ethernet connection. So it's not an absolute necessity to have a PoE switch. Now, when we look at this unit flat on the screen, it just looks like a dish, and it's hard to picture how you might actually set this up in a room. And there are a couple of different ways it can work. So for example, you can mount it on the ceiling, and it ships with all the appropriate brackets to do that. You then, of course, run the Ethernet cable back up through the plasterboard, and you get a nice flush fit. You can also mount them on the wall, and the placement of these units within an environment is a really important decision in terms of how good the connectivity is going to be in various parts of the room. Also, don't worry if you don't like the idea of having a blue light shining on the unit at all times, because you can disable that centrally. Let's go back and look at some other general purpose Wi-Fi units. The next one is the AP/AC LR. LR being for long range. And you can see that you get another 61 meters of range here with this particular unit. Now, as I mentioned earlier, this is the maximum range. You're not going to get the full throughput if you extend it all the way out to 183 meters. But certainly you can go further than with the light unit before the signal degrades to the same extent. These devices, like the in-wall unit, also support the fast roaming that I touched on earlier on. So you may have a combination of in-wall, AC light and AC long range units in the one premise, and devices will simply jump from one to the other as they move around. Next up is the Pro unit. And the Pro gets a big bump in speed, particularly on that 5 GHz spectrum. Likewise, also a big bump in users as we continue to move further right on the more users, more performance scale. This is a physically larger unit too, about double the size of the light on the left of the screen. So that may also be a factor when you're designing your network. And lastly, there's the HD unit, and that's HD for high density. And as you can see here, we're now talking about up to 200 users. And both 2.4G and 5G get pretty big bumps in speed as well. Of course, another factor that does determine the performance of these units is what those connected users are actually doing. It's one thing to be in a cafe where people are sending email and updating their Facebook status, but it's quite another to be in a hotel where people may be kicking back on their bed watching Netflix with high-def video. It's because of the fact that there are so many different use cases for these units that we have the range that you see here in front of you. And this again comes back to the earlier point on modularity. There is no one size fits all here. You have to look at your specific environment, what your needs are, what your users are going to be doing with the Wi-Fi that's available, and then determine the best fit for that environment. Now, over time, that may also change. And part of the value proposition of deconstructing the traditional single unit that does everything is it makes it a lot easier to later on decide that you need to add more units and expand the scope of your network. Let's go on and look at one more class of Wi-Fi product, and that's outdoor Wi-Fi. And we'll begin with the mesh unit. Now, being an outdoor unit, it is of course weather resistant, and you can mount these just about anywhere. They're highly resilient to the conditions, and when you do connect an Ethernet cable into the bottom of this unit, there's a rubber grommet which seals it snugly in place in order to keep water out of it. So I actually have one of these sitting outside in a very exposed location, but that's precisely what it's designed to do. At the other end of the spectrum is the Mesh Pro. And as with the previous two lines of access points we saw, it's a physically larger unit providing more speed, inevitably to more users. unlike the mesh unit, it does also have a secondary Ethernet jack. So the unit on the left just has the one jack, which like all the other devices takes power over Ethernet, whereas the Mesh Pro does allow you to connect another device into this one here. Now, just for a sense of what this might actually look like in a deployment, imagine a fair in a town. So lots of outdoor space spread out across some distance, and then a combination of both the Mesh units and the Mesh Pro units. Now you'll recognize the Mesh Pro units straight away. They're the big flat models like we saw on the previous screen. The Mesh units are a little bit harder to identify here because they're plugged into AirMax antennas. It's still the same unit as we saw on the previous screen. It's just simply plugged into a larger antenna in order to get it some more range. One of the really neat features about these mesh units is they can do what's referred to as a multi-hop. Now, let me explain what that means. The other units that we've seen so far can wirelessly uplink to another access point. So, for example, one APAC unit can create a wireless connection to another APAC unit, which has a wired connection back to a switch. These units here, though, can have multiple connections wirelessly, one after the other. Let me show you what that looks like. Let's imagine we have a switch, and one of these units is connected via Ethernet cable. So this unit is now the base station, or the root. You then have another unit that is one wireless hop down. So this is the first hop. And as I said, you can do this with the other Wi-Fi units as well. You may actually have multiple units that are one hop down from that base station. But what makes the mesh units unique is that you can now do another hop. So you can imagine in a scenario like the town fair we just saw, where you're going to want to have multiple units over some distance, being able to multi-hop is actually very important. And you can then have multiple units chained down beneath that. You can still multi-hop further down and have, say, a third or fourth hop, but you are going to start incurring greater degrees of latency as well. So the design of these networks becomes very important. One last thing on the mesh units. They're also self-organizing. Now what that means is that if one of these units was to drop off, so let's say someone unplugs it, dependent units can then reroute their upstream connection back to another unit that they can still see. Of course, this now puts more overhead on that unit which has now picked up that rogue one whose upstream hop just disappeared, but it's a great mechanism of the network being able to self-maintain and repair itself if something goes unexpectedly wrong. So that's it for Wi-Fi access points. Let's now move on and start talking about switches. And we're going to start really simple with a switch 8. It's the smallest switch in the UniFi product suite. It has 8 ports, can be PoE powered, and also has a single PoE pass-through port. So that far right port on this unit can provide the one PoE connection. Next up is a switch 8 60 watt. And the main difference here is that we're now seeing 4 PoE powered ports. So if you were to have a very small network, perhaps with a couple of access points, this could be a good solution because it could provide power to both of them while still having a bunch of ports left over to connect other devices such as, say, network attached storage or perhaps a printer. Stepping up from there is a switch 8 150 watt, and now we're getting towards 8 PoE enabled ports. This unit also comes with brackets that can be used to wall mount it. And in fact, both the two smaller units can also be wall mounted, and they've got mounting holes on the back of the unit which can be used to hang them in a convenient location. If not mounted, all of these are units which can easily sit on a desk. Let's step it up and go to rack mounted units. And the first one is a switch 16 150 watt. And as the name suggests, it has 16 Ethernet ports. And of course, all of these are gigabit Ethernet ports as well. And in this case, every one of those 16 ports is also Power over Ethernet enabled. Now you don't have to rack mount this. In fact, as you can see from the image, it doesn't have any mounting points. They come as separate brackets, and that allows you to mount them in a couple of different ways. For example, like this. Rotate the brackets one way and you can mount it flush against a wall. Rotate them the other way and it becomes rack mountable. So you've got some flexibility there in terms of where you actually decide to locate the unit. Getting back to other switches, we can move along to a switch 24 or a switch 48. And again, they're very self-descriptive names. This is just the number of ports they support. What's important here though is that these are not PoE-enabled ports. So you're not going to be driving any of those access points we saw earlier on directly off these switches, at least not without a PoE injector. Both of these units also have the same versatile mounting capabilities as the Switch 16 150 watt. Lastly is the Switch PoE 24 or 48. And really what we're doing here is adding Ethernet, and these are only rack mountable. And you can see that based on the mounts you see on the front of the unit. These would go great in an environment where you're actually driving multiple PoE-enabled devices downstream off the switch. So for example, where you might have a bunch of wireless access points which can take power directly from the ports on the switch. So as with the access points, you've got a whole bunch of configurability here. And again, we come back to this whole premise of modularity. Pick and choose the parts that work best for the environment that you're installing into. Of course, you can use multiple units, whether that be a couple of little switches in the home, because you may have an environment, like in my house, where I need a switch in the home office due to a bunch of appliances which require physical Ethernet connection. Or it might be a larger scale commercial style environment where you're going to have an array of rack mounted switches and possibly take advantage of those SFP ports as well. Let's now move on, and I want to talk about the security gateway. Now I'm going to show you two security gateways, starting with this unit here. Now I showed you this on an earlier slide where I talked about the basic premise of a UniFi network layout. And the security gateway provides firewall capabilities as well as allowing you to create VLANs. So for example, you might want to create different virtual network segments for the accounting and the marketing departments. Or perhaps it's a cafe style scenario. You want to have one VLAN for the staff and another VLAN for the guests. It also has VPN capabilities, so you can create a site-to-site VPN tunnel. Stepping up from this unit is the Security Gateway Pro. And we're obviously now looking at a rack-mounted unit. And inevitably, this is intended for a larger scale rollout. It has twice the amount of flash storage, 4 GB of DDR3 rather than 2 GB of DDR2 per the smaller security gateway. It's got 4 times the memory, 2 GB versus half a gigabyte. The processor is twice the speed. The Pro runs at 1 GHz, and it also supports a much higher line rate. So for the home or smaller commercial rollouts, the security gateway is going to be just fine. And it's only when the rollout size increases sufficiently that you're going to be looking at the Pro and then of course mounting it in a rack as well. Both of these units route traffic out to the internet. And I showed earlier on how the security gateway would plug directly upstream into a device such as an ADSL modem. Now, because they can route that traffic, they can draw some really interesting insights from it. And one feature I particularly love is Deep Packet Inspection, or DPI. Now this is actually a DPI report from my own network. And what I like about this is that I can look at it and get a really good understanding of how much traffic is going out through my network and what services it's going to. Now, most of this comes as no surprise to me. My family watches a lot of Netflix, I know that. I tend to use Twitter and Facebook quite a lot. And per the image in the bottom right of the screen, I also use Microsoft's Remote Desktop Protocol to administer some servers I work with. DPI is an enormously powerful feature that can give you some really interesting insights about your network. And as with any network built on the UniFi ecosystem, it doesn't matter whether it's a small home rollout or a large commercial rollout, all the same information is available to you. But there's one more really essential component of a UniFi network, and it's the controller. So this is the unit that actually allows you to configure the entire network. And that includes running the software that presents things like that DPI report we just saw. Now, there are many different ways that you can run a UniFi controller. And I'm going to begin by talking about software solutions. If you'd like, you can run the UniFi controller as a Windows service, be that on a PC or a server. You can also run the controller on a NAS device. Some people even run the controller on a Raspberry Pi. Now, that may not be something that everybody feels comfortable with, but the really important thing here about the controller is that you have a huge amount of flexibility as to where you decide to run it. In keeping with that theme, you can also choose to run it on a hardware device. And in this case, I'm talking about a UniFi Cloud Key. So this is a Ubiquiti device that looks like a very large USB stick. The only difference is that you plug it straight into a switch over Ethernet and it's powered via a PoE-enabled port. This is what we're going to be using later on in the course to set up a network. And it's a great solution as it is a dedicated product designed purely to run the UniFi controller. Now you can also go and use a UniFi service, and Ubiquiti provides the option to run the entire controller software for you via their own cloud product. Now, particularly when you're managing much larger installs, this makes a lot of sense. And certainly my preference out of all the available options here is to focus on the products that are best supported by Ubiquiti. So for example, the Cloud Key, and incidentally, this doesn't require an internet connection. You don't need public cloud access in order to run a Cloud Key. It can be an entirely isolated network. Or by running the Ubiquiti managed service. Now then, of course, you do have a service fee. And again, that makes sense in larger rollouts. But that's also a factor which may drive people back towards the left to the likes of the Cloud Key. Regardless of which controller implementation you choose, all of these run the same software. And this is the consistent experience you get across all of those products. This again is my home network. And whether I'm managing the network in my house that's using the Cloud Key to provide the controller software, or a large commercial rollout that's possibly using Ubiquiti's managed service, I have the same user experience in the same familiar environment. So that's the UniFi product line. Let's move on and have a look at designing your UniFi network.